Equivalent fractions. Equivalent fractions have the same value even though they look different. For example, the fractions 2/6, 3/9, 4/12, 5/15 are all equivalent because they are all equal to 1/3. Why are they all equal? Because when you multiply or divide both the numerator and the denominator of a fraction by the same number, you don't change the value of the fraction. So, 1/3 is equivalent to 1 times 2 over 3 times 2, which equals 2/6. 1/3 is also equal to 1 times 3 over 3 times 3, which equals 3/9. 1/3 equals 1 times 4 divided by 3 times 4, which equals 4/12. We can go on indefinitely because each fraction has an infinite number of equivalent fractions. The important thing is to use the same multiplier or divisor for both the numerator and denominator. This is correct. 2/3 equals 2 times 4 over 3 times 4, which equals 8/12. However, 2/3 equaling 2 times 4 over 3 times 3, which equals 8/9, would be incorrect. When you use different numbers at the top and at the bottom, you change the fraction's value, and thus you do not get equivalent fractions. Remember, equivalent means equal. How do you find equivalent fractions? One way is to use multiplication. 3/7 equals 3 times 2 over 7 times 2, which equals 6/14, which then equals 6 times 2 over 14 times 2, which equals 12/28. The fractions 3/7, 6/14, and 12/28 are equivalent. Another way to find equivalent fractions is division. For example, 24/36 equals 24 divided by 2 over 36 divided by 2, which equals 12/18, which then can equal 12 divided by 3 over 18 divided by 3, which equals 4/6. The fractions 24/36, 12/18, and 4/6 are equivalent. In the previous examples, we were looking for fractions equivalent to a given fraction. To obtain equivalent fractions, we multiplied or divided both the numerator and the denominator of a given fraction by the same non-zero whole number. However, sometimes the problem we have to solve is different. What are we going to do in case we are given several fractions and need to determine whether they are equivalent? There is a simple way to do this. Step 1. Find prime factorization for both the numerator and denominator. Step 2. Divide both the numerator and denominator by the greatest common factor. Step 3. Repeat steps 1 and 2 for each fraction that you are considering. Step 4. Compare the final fractions and decide whether they are equal. To clearly describe this method, let's consider several examples. Example 1. Are the fractions 2/3, 6/9, and 10/15 equivalent? The fraction 2/3 is already in its simplest form, since both the numerator, 2, and denominator, 3, are prime numbers. 6/9 equals 2 times 3 over 3 times 3. Cancel out common factors, 2 3's, so the fraction 6/9 is equal to 2/3. 10/15 can be represented as 2 times 5 over 3 times 5. Cancel out common factors, 2 5's. So the fraction 10/15 is equal to 2/3. Each fraction is equal to 2/3, hence the fractions 2/3, 6/9, and 10/15 are equivalent. Example 2. Are the fractions 1/4, 2/8, and 5/20 equivalent? The fraction 1/4 equals 1 over 2 times 2 is already in its simplest form, since there are no common factors in both the numerator and denominator. 2/8 can be represented as 1 times 2 over 2 times 2 times 2. Cancel out common factors, 2 2's, so the fraction 2/8 can be reduced to 1/4. 5/20 can be represented as 1 times 5 over 2 times 2 times 5. Cancel out common factors, 2 5's, and you are left with 1 over 2 times 2, which equals 1/4. So the fraction 5/20 can be reduced to 1/4. Each fraction is equal to 1/4, hence the fractions 1/4, 2/8, and 5/20 are equivalent. Example 3. Are the fractions 4/4, 11/11, and 22/22 equivalent? 4/4 is equal to 1. 11/11 is equal to 1. 22/22 is equal to 1. Each fraction is equal to 1 because for each fraction, the numerator is equal to the denominator. Hence, the fractions 4/4, 11/11, and 22/22 are equivalent. To better understand the material, practice solving the following problems. Are the following fractions equivalent? Problem 1. 9/12 and 6/8. Problem 2. 2/7, 4/14, and 8/20. Problem 3. 7/14, 2/4, and 5/10. Problem 4. 7/7 and 105 105. If you need help, check the solutions of these problems in the next video.